Okay, I'm looking at number 3. Number 3 gives me the basic function 2 to the x. It gives me points off of 2 to the x. It gives me the graph of 2 to the x. We are going to use that and we're going to transform it. And there's 2 things we're going to do to it. One thing is we're going to make a negative here. The other thing is we are going to add 6. Both of these have different effects. So negatives always, always, always are some form of a reflection. So the direction that you reflect depends on where the negative is. This does not say make x negative. This says make your outputs negative. This says make your y values negative. This is a y value reflection. This is a vertical reflection. So as I told you in class, I always picture it. And if I move it vertically, I just flipped over the x-axis. So this is a vertical reflection over the x-axis. So I'm just going to kind of throw a sketch down here real quick. That if that's all that happened, this is be what I'm looking at.
Dog.
But after I have...
Dog.
Go over there. Sorry, that's my kid. After I've reflected, now I have to add 6.
Dog.
That would be my husband.
Dog.
Stop it. This does not say x plus 6. X has been done. It's completed. We are not changing the x values. We are just going to be translating. Please help me.
Okay, stop.
So we are going to be moving up, down, left, or right, but because I didn't do it to the x, we are going to be doing it to a y. This is a vertical translation. Specifically, we are going to be moving up 6. So I could picture this blue graph that I had down here. It's going to be, well, currently it's down here at -1. I'm going to move it up 6. Any point that was down here will be moved up 6. So I get this kind of shape. So that's for the graph of it. The actual points, though, you'll notice I did not move left or right. All that I moved is I made negatives, I flipped it, and then I added 6. So I'm going to do that to the output values, the y values. I'm going to take that y value, I'm going to make it negative, then I'm going to add 6. But the x value should stay the same. So -2 plus 6 is 4. So the same thing for the point above it. I'm leaving x the same, but I'm taking the output value, the y value, I'm going to make it negative, I'm flipping it, and then I'm going to add 6. So then I'm going to get a 5 here. I'm going to leave x the same. I'm going to make the output negative and then add 6. So even if you forgot that it meant to flip and then translate 6 units up, you could still graph the point -1, 5.5, 0, 5, 1, 4. And so I missed my dots a little bit, but we still have that same general trend. So I want the domain of what I wrote, the range of what I wrote, and the horizontal asymptote of what I wrote. So domain is left and right, and I see definitely it extends forever to the left. There's an arrow pointing left. There's technically, it's heading to the right. It's going down at the same time, but the domain will be all real numbers. There's no transformation that we will do that will take it out of all real numbers for the domain. But the range is the thing that is limited. So originally, on that parent function, it approached the x-axis, but it technically never touched the x-axis. So it used to be sitting here at y equals 0. When I flipped over the x-axis, the horizontal asymptote's still there. But when we did the translation, remember everything moved up 6. So the horizontal asymptote also moves up 1, 2, 3, 4, 5, 6. That's the line now that we approach but never touch. So the horizontal asymptote is not just a number. I'm not just going to write 6. I'm going to say it is the equation y equals 6. It used to be y equals 0. It's now y equals 6. So the range is these y values that are below that line because I stayed below the line. So I'm going to say it's the y values less than 6. And it's less than because I'm below the line. So it used to be greater than because I